Alright, so today we're going to be going over conditional probability, but practice questions only. So our first question states that a box contains 1 black, 3 green, and 2 red marbles, and that 2 marbles are selected randomly without replacement. So our first question is the probability of no blue marbles. So you might want to jump into the question right away and say that we have no blue marbles, so you're going to say that the probability is going to be equal to 0 because we have no blue marbles. But that's not actually what the question is asking. The question is asking what the probability of getting no blue marbles is. And since we don't have any blue marbles, that means there's a 100% probability that we're not going to get a blue marble. Or, in other words, since it's probability, which means that our answer has to be between 0 and 1, probability is going to be 1. So now for part B, we want to find the probability that both of the marbles selected are going to be the same color. So the first thing we want to do here is we want to find out how many total possibilities there are for selecting all our marbles. And if we count it up, we have 1 black, 3 green, and 2 red, which means that we have 6 marbles in total, and we have 2 marbles selected at random. And since they're without replacement and the order of them doesn't matter, we need to put it through combinations of 6 choose 2, which will get us 15 total possibilities of how we could select marbles. Now we need to find out all the ways that we could select both of the same color by using the same kind of format of combinations. Well, for black, we only have 1 black marble, meaning that we can't have black for this equation because we need both of them to be the same color. And we can't have both as the same color if we only have 1 black marble. So our probability of black won't matter. But now we're going to have our 3 green, and we're going to have our choosing our 2 out of the 3 green. So 2 out of the 3 green, which will be 3 choose 2. And then finally, we need our choosing our 2 red marbles. And since we only have 2 red marbles, we're going to be choosing 2 out of the 2 red, which is going to be 2 choose 2. And since these are going to be independent events, because either we could have choosing the red or choosing the matching green marbles, we'll have to add our events together, which will give us a final answer of 3 choose 2 plus 2 choose 2, all divided by the total amount of ways that we could get an answer, which is 15, which, if you put it into your calculator, will give us 4 divided by 15. So our probability of both the same color is 4 over 15. And now for part C, we're going to look for the probability that both of the marbles selected are red. So we're going to use the same kind of format as our last question, and we're going to even use one of our equations because there's only, as we see here, there's only 2 choose 2 ways to get both of the marbles to be red, which is equal to 1. And to find the probability, we always have to divide it by our total number, which will get us 1 over 15 for the probability of both being red. Alright, now our second question is, in 2006 to 2007, the shooting percentage leaders in the NHL were Jordan Staal and Alex Tanguay. Their percentage for Jordan was 26.0, while Alex was 22.8. Assuming that the shots are independent and both players take 2 shots in a random game, what will the percentages be for each of the questions? Or what will the probabilities be for each of the questions? So our first question is the probability that Alex scores with both shots. So what we're going to do here is multiply the probability of him scoring a shot 2 times, because we know the probability of him scoring a goal already because it is 22.8. So all we need to do is multiply those together, but to make it a little bit easier, we're going to change it from percentage to decimal. So this will become 0.228 multiplied by 0.228, which will give us a percentage of 5.1984%. Now part B is asking to find the probability that Jordan scores one of the two shots. So we can start off with writing the same thing as before. The same thing as part A, where we know the probability of him making a shot because it's in the question of 26.0, and we know that's the probability of a make. But since we want to find the probability of him scoring one of the two shots, that means we have to multiply it by, instead of another make, a miss. But in order to get a miss, we need to take the complement of a make, which just means we're taking 1 minus the 0.26. But we're not done, because this could still be changed around, because right now we have it as him making the first shot and missing the second shot. But that could be changed to him missing the first shot and making the second shot. So what we need to do is have it multiplied by 2, choosing 1, which will give us the two different ways that he could make the shot, multiplied by the probability of one that makes, multiplied by the probability of the make, and multiplied by the probability of the miss, which will give us 0.3848. And now finally, we have our question C, which is saying that Jordan scores both of his shots while Alex misses both of his shots. So what we need to do is we need to see that both of these need to happen at the same time. So we want, if we set event A to being Jordan scoring, and we set event B to Alex missing, then what we're able to see is that we want to find the probability of A and B happening. So what we'll need to do here is we'll need to use our probability formulas that we learned in the lesson, which means that the probability of A and B is equal to the probability of A multiplied by the probability of B. But this is only true because we already know that the shots are independent, because this is a part of our independent formula. Now, what we're able to do is we're able to plug in our numbers of Jordan scoring, which will be 0.26. And since he has to score both of the shots, instead of just multiplying it by 0.26 again, we're just going to square it. And then we're going to multiply it by Alex missing, which is 1 minus 0.228, because it's just going to be the complement of him scoring. And the same thing as the Jordan making the shots, because he has to miss both the shots, we have to square it. Instead of just multiplying it by again, it just makes it look neater. And if you put this into your calculator, it will give you 0.0403 for your probability. Okay, now we have our third and final question, which says that there is a shipment of 10,000 laptops being sent to a company in which 2% of these laptops do not work. So the first thing we want to do is we want to find the probability of the first 5 laptops all working. So what we want to do is we're going to want to find how many laptops actually work, which will be our A, and how many laptops do not work, which will be our B. And since we already know that there's 10,000 laptops and when 2 of them and that 2% of them do not work, we're able to just do 10,000 multiplied by 0.02, because that's 2%, and this will tell us how many laptops do not work, which will end up being 200. So we know that our B will be 200 and our A will be 10,000 minus 200, which will give us 98 500. Now to set up this question, what we need to do is we need to find the probability of our first laptop working, because we want our first 5 laptops to all work. So we know that we have 9,800 working laptops, and we're going to divide that by our 10,000 total laptops. And now we need to multiply this by, since we have one less laptop that works and one less laptop overall, we need to take one from both. So we'll have 9,799 over 9,999. And now to get to the 5 laptops that we need all working, we need to do this 3 more times, of 9,798 over 9,998 total laptops multiplied by 9,797 over 9,997, and finally multiply it by 9,796 all over 9,996, which will give us the total probability of the first 5 laptops all working being 0.9039. But now for part B, we want to find the probability that the third laptop taken will not work. So we're able to start this question the same way as our last question, where we have our first laptop working because our first and second laptop we know will need to work, because that's what the question is asking. So we'll have 9,800 over 10,000 multiplied by 9,799 divided by 9,999, because we're still taking one laptop that works away and one laptop total away. And now this is where we need to use our broken laptop. So we know our broken laptop is our event B, which means that we only have 200 laptops. So instead of putting our working laptops in the numerator, we put our broken laptop. And same as the denominator, we're going to divide it by our remaining laptops, which is 9,998, which will give us a probability that our third laptop will not work of 0.00192.